I'm not sure if the output which I'm getting is right or wrong. For experiment 3,
Experiment 3. Okay.
can I share my
Yeah,
screen and show you the experiment?
yeah, sure, sure, sure.
Okay, I'm getting the same output as what I'm getting in the simulation. So
Hmm.
let me show you.
Share your screen.
Yeah. I guess my screen is visible. Hello.
Sorry, yeah, it's visible.
So I don't know. Whenever I click on run, it's taking too much time to get simulated.
Hmm.
What could be the issue?
It's trying to okay, it's trying to calculate your DC point. It's taking too much time to calculate.
Okay, this is what I'm getting.
Okay, show your ramp and sine wave.
Okay. So this is my sine wave.
Okay.
Ramp, I can't show it separately because it was in this particular subcircuit.
Mm, okay, your oscillator is in that X1. Oh, wait.
Yeah, in this my
Okay, okay,
oscillator
okay.
report.
You should have removed it and okay. You can't plot this now.
Oh,
Okay, okay. Anyway, go. Oh no. Wait. Go back. Okay, minimize this window. Show me the
ah,
sine wave. Okay, go inside that X1.
yeah.
Okay. Okay. I wanted to see this V in
Ramp.
one, V in A, and V in A plus, or V
Okay.
in any one of them. Can you? I
Okay,
can't see
so
the.
one second. We can run that particular thing separately.
Okay,
Experiment 2.
fine.
So this is experiment 2.
Show me explain.
Okay, so I think I'll have to make a source here.
Uh, Oh wait, one more thing. Your sine wave is how? What's the amplitude of a sine wave?
0.5 volt.
Oh, you can reduce the amplitude, right? And you have check it once. Okay, anyway, run it.
Reduce. Okay. Yeah.
Amplitude and you can check. It's 5 or 6.
You want to see,
Ah,
yeah, this
that's correct.
particular here, yeah, because we have added this capacitor here, and
Hmm.
due to virtual short, the 2.5 volt bias will be added automatically.
Correct.
Yeah,
Yeah, that's fine. Now,
this is my RAM.
yeah, okay. Yeah. So for this, you are getting your wait. Why is the ramp? Oh, no. But the bottom, it's this is 2.5. Why is it 2.1 ramp at the lower point?
Um,
Because the top it's okay, but lower it is.
yeah, okay, this is my
That shouldn't
circuit.
happen. That's the problem.
Hmm.
That's why you're getting that kind of output. So your sine wave should be within your ramp for it to work properly.
Hmm.
The sine wave kind of should be embedded within the ramp. It's kind of the other way around now.
Okay.
So that's the
Should
problem.
I adjust the amplitude of my sine wave?
Yeah, reduce it. It should be.
Okay. And reduce this to 0.4.
Huh.
Okay. Okay.
Okay, now check the this
Final
recording
output.
screen.
Okay. Why am I getting this?
I remove the source from this thing. There are two sources in parallel.
Okay.
Yeah?
No. The problem is with this
Remove
source
that.
here.
Yeah, that's okay.
Are you able to see the error?
No.
One second. The screen got freezed. Mm. This is the error I'm getting.
This is Go to your transient ones, settings.
Yeah.
Start. Click enable that start with 0 volts.
Hmm.
Okay, now run.
Okay.
Run, run.
Okay.
That's correct. Right?
This is what expected. Huh?
Yeah. So will show me the sine wave. No.
Yeah. It's oscillating
Okay,
between
but
4 and
it
9.
should have been within 2.5. So separate out the, make it into different windows. Maximize plot, separate all of them in different windows.
Sorry, can you come again?
Maximize your plot window.
Okay.
Separate the plots. Add right click.
Uh,
Uh, no, add. No, not add tracer. Add plot plane
yeah.
above this. Yeah. And now
Uh,
just drag and drop the that green thing, the label you see at the top. Just drag and drop that.
okay.
Okay. Now,
One
which
second.
is positive? PWM positive. Remove the remove one. Keep only one. Don't keep two. Hello. Freeze here. Okay. No, no, it's correct. It's fine. Okay. Take the blue one. Remove any one. Remove the red one. Uh, Delete the red one.
I'm audible now.
Yeah. Delete the red
Yeah.
one.
So V and 004. The blue one is the positive and the red
Yeah.
one is negative.
Delete the red one. I want to see the opposite.
Sorry?
Delete the red one. It's not cluttered. I can't see it.
Uh, okay.
Okay. Yeah. Zoom.
Mm.
Yeah. Mm, yeah. It makes sense. Yeah. This is correct.
Okay.
Now plot the current through inductor.
Mm.
I don't need that buffer. Do you need it?
I don't know. Last time Anirudh brother has it. Okay, this is the current through the inductor.
It's wrong. Inductance is low. Go back to go back to the schema.
Okay.
500 micro. Yeah, 60. So load was 32, right?
Mm.
What's the frequency?
Frequency somewhere around 312 hertz.
Hertz.
Yeah.
Okay. So it should also work for the maximum it should work for. What was given in the instruction? What frequency you should test this for? Manual what was given? 812.5. Okay.
It is given as 312.5.
So you are so what your cutting frequency is by uh, how did you calculate it?
Sorry?
How did you calculate it? 500 micro.
Sorry, your voice is not very
So
understandable.
how did you calculate inductance?
Mm, I think it was given somewhere.
PDP data. That's
No, I think it was said by Anirudh.tv. to use that particular inductance
And
because we
then
don't have that
convert
speaker with us.
and then convert somewhere there. No, still file. Next page. Wait, God. There it is.
Ah,
200s to thousands. Make it 1000.
okay.
Hold on. Yeah, wait, don't wait. I'm making that same way. Yeah, okay, this is fine. This is what you should get back your sine wave basically. Return the current, you should get back your sine
Okay, so now does it look good?
wave. So just what you're doing is you're taking a sine wave, you're generating inverted and non-inverted signal, and then you are converting them to the PWM, and then you are just demotivating
Sir,
the
you're
PWM.
not very
Yeah, yeah.
audible.
A lot of
Yes.
disturbance.
Uh, Hello, now it is audible.
This
Hello,
is better. Yeah.
it's better, right? Yeah, sorry, because my microphone is not like okay. So yeah, so what we're doing is we are taking a sine wave and we are converting it to a PWM, and we are just demodulating the PWM through a filter. So that's what you are doing. You should get back your whatever sine wave you're given, you should get back that. Okay, that's what we are trying to do. Okay, so this is okay. This is what you should have got. Okay, is this clear? So, and then the inductance is a little bit low, I think. Then there may be an offset also. Is your PWM properly are they properly inverted? There should be
Uh,
exactly 180 offset.
Here, huh?
No. PWM outputs. I mean, if it is both should be inverted.
Mm.
If there is a bit, it's not correct, then also you'll have this problem.
Is this right?
If it is high, this should be low.
One second.
Yes.
Yeah. These are the PWM outputs.
Hmm.
Is it fine?
Right. I don't think over. Oh, okay, it should be fine. I don't think it's a problem.
I mean, they're not
Yeah.
exactly complementary to each other, right?
I mean, whatever you'll get for the positive cycle, you should get the see. For the positive PWM will be inverted of the negative, so you should get the opposite. 180-degree phase shift should be there between these two with respect to the sine wave. Yeah,
Okay,
it's
so
okay.
that means that the PWMP will be 180 degrees phase shifted version of PWM.
Hmm.
It need not
Wait
to be
there. Phase,
exact opposite
yeah, phase is with respect to the sine wave.
sign.
Yeah,
Okay. It need not to be exact opposite. So the
yeah,
phase should be
no.
with respect to sign.
Yeah,
Okay.
phase is the reverse itself. So, yeah, it's okay. I
Mm.
think it's okay.
Okay, the only mistake we have done was the amplitude of the sine wave.
Hmm.
It should be in between the
I mean, your
PWM
design.
key.
I mean, for second. What was the second experiment?
Good. Shall I open second experiment?
No, no, what it was. Just I want to know what it was.
It was just a PWM-P and PWM-L.
PWM. Okay. Oh, but that itself was second experiment.
Yeah.
So I think yeah, it just V in minus and V in plus should be exactly 180 degree. Is that the
That
case?
that is fine.
That is fine. If that is fine, then yeah, it should also be okay.
Okay.
Elements, okay, okay, that's correct. Yeah, it's fine.
Hmm.
Seems fine. Yeah, this should be fine. Oh, your oscillator, the ramp is not amplitude is not correct. It should be that was a problem majorly.
Hmm.
Go to your ramp X1
Okay.
inside. Uh, 25, 10, 1K, 5K. This was for what frequency? This was
For 5 kilohertz.
5 kilohertz.
Yeah. So not exactly 5 kilohertz, but it was a little off by 100 hertz or something.
How much is this? Make it okay. Show you can't show the outputs here, right?
Yeah. I cannot, I guess.
Okay. Yeah, the ramp was not correct. That's why the amplitude of ramp was not correct. That's why.
Okay.
I think 25K. Mm, Make it 10 and 50. Let's see if that works. You can
10 and
change it. R2 as
no,
10.
no. Actually, I can just run this particular circuit separately and show it out because it
No,
doesn't
no, no,
depend
no. You
on.
just make it okay separately.
Sorry?
You can just run this circuit, right? This doesn't
Yeah,
need
yeah,
any input.
yeah,
Okay, run it.
yeah, yeah, running. Okay.
Hmm.
Ah, okay.
Okay.
Here itself, it was oscillating between 2.1 and 3.
Yeah, that's not correct.
Yeah.
It should be 2. Oh, no, okay, okay. Go forward. Go to longer term.
Okay.
What is at the end? What it is? Is it correct there?
No, no same.
Oh, no. Okay, make it 10 and 50. Let's see.
Okay. So I'll change the transition.
And that is okay. That you keep it. That's not a problem.
Okay. R1.
R1 is also fine. R2 and R3.
Okay. 10 and 50. Fine.
Uh,
I'll change. Mm,
fine.
yeah, okay, fine. So is it fine for the simulator to take this much time?
Yeah. Is it okay
Okay.
now?
Now I think it is looking fine.
Maximize. Let's wait. Let it complete. Let it complete. Let
Okay.
it.
Fine.
Can
Ah,
you? It's fine, right?
yeah, it looks fine.
Can you explain what had happened?
Uh, so we are decreasing the current right now.
So
So
correct. That was correct answer. What it does?
okay. So so sorry. Can you just explain me what is the effect of that?
I think how much current was going through
Oh,
the LM this thing, comparator, and now how much it will go.
So at least the current got decreased by tenfold.
Hmm. Tenfold. So lower current. So what's the advantage?
Okay, so this has to do something with the comparator or with the capacitor.
I mean, the lower current in general, what it does.
Easier switching, eh?
Huh? Easier.
No, I'm not sure.
Tell. Okay, no problem. Maybe
Faster
something.
switching?
Oh, yeah, that's it. So you'll have it is a speed increase. Your speed will be high. If you are lower currents, your speed is higher.
Okay.
Okay, so it's easier on the op amps. Okay,
Hmm.
so that's it.
Okay, fine.
Yeah, now it should be okay. So yeah, even debugging is like this, and you have to just go through. Okay,
Okay.
there is no golden rule for this. You just have to understand concepts.
Okay.
Okay.
So, one more thing.
Hmm.
So far everything is good.
Hmm.
So for the fourth experiment,
Hmm.
let me show you. Okay, so this is the fourth experiment.
Okay.
So if I close this. Okay, so when I run this, you get an
What was it? Okay.
sorry, something is off here. Okay, there's no audio source. One second.
And run. Okay. Anyway, run it is.
Yeah, one second. There's no audio source here.
Okay. Okay.
And then,
Ah, no. I just that's enough.
uh,
No.
okay.
That should be
So,
one. No,
oh, okay. Okay.
one. That's it.
Yeah.
Transient. Okay. What's the cutoff? Click on that green label. We click on that green label. Now we will push it. Uh, 149. Is that correct?
So
What
they've
is it?
asked for 160,
150 something, right?
156.
156. So where is it off?
So we are getting it at 149.
Where are you setting the values? This R1 and all?
Okay, I'm setting in the separate parameter.
Okay, where how much you've taken?
R1A is equal to 10 kiloohms and
How did you calculate these? Can
we've done a derivation.
yeah,
So
what and all what is the final results?
so we got that transfer function and from there we introduced.
Yeah, okay, fine, but I understand. What is the transfer? I mean, you should have got something, right? The relation between R's.
Okay.
Uh, okay. Somebody else have done this relation between R. I think yeah, Krishna. Yes, somebody raised their hand.
Yes, good evening, sir.
Yes,
Sir, I had calculated the relationship between the different resistance values.
yeah.
What I got for R22, I got it as 2 times of R1.
R2 has 2 times of R1.
Yes, sir.
Okay, that's fine.
And R1 is 199 times R3.
Okay, yeah, that's correct. So we should get exactly no how you, so if that's correct. So should get exactly at that point. Have you come down? Come to your
Mm.
values. Show me your values.
Yeah. Okay.
Okay, what is CA? 1 micro.
Yeah.
So for 1 micro, how much R1 should be? 1 into 10 plus 6. What is the cutoff? 156.25, right?
Yeah.
1, 2, 3, 4, 156.25 into. Yeah, you have taken 10K, right? 10K. It should be 10.185 something, right?
Okay, but we don't have that components yet. So
Ah, fine. Sorry, I wanted. Okay, you don't. So, but you have 20.55.
somewhere
Look at
around 21 I
25.
have.
Ah, that won't work. How? Okay. So, what? Uh, this
Even
year set.
55 I don't have. I have somewhere around 51 ohms.
Oh, 51 should be. Okay, 51 now. Ah, 51 is fine. 51 you will get. That's
Mm.
51.18 is what is required for R3.
Mm.
There should be 10 point. Make it 10 point. Wait a minute. 10.185. 186. Make it 186.
Okay.
Okay. And yeah, it do twice of this. 20.371. 372. Make it 372.
Mm.
Okay, now run it. One
Mm.
second. How much
It,
is it?
it came to 150.
150. Yeah, that is 55. Make R3 as a 51 point. R3 is 55.
Sorry.
Wait. R3 is 55. Make it 51.186. Now run it. Now it's not. Is that correct? Zoom in and you can cursor.
Okay.
Uh,
Yeah, it
that's
seems.
correct, right? Yeah.
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 Mm.
Okay. And yeah, AC analysis you can do it in logarithm also.
Okay.
It's 1000. Okay. What is linear 20? Okay. That's fine. Yeah, it's clear. Okay, right?
Yeah,
I think
it's
it's
okay.
fine. Yeah.
Okay. Okay. At least for the in simulation, we have to fine tune our values.
Yeah. Yeah. In practical, it's yeah. I understand there are no resistors. That's okay. But this in simulation, you can put exact values and check it,
Mm.
and then find and then look what are the components you have, and then simulate it again and see if your results matches. That's all.
Okay.
AC analysis, I think you have to generate a signal. How are you doing it in practically?
Okay. Okay. You're asking in the actual circuit how we are doing it.
Yeah.
Okay. Actually, regarding this, I have a doubt.
Hmm.
So I'll show you. Let me get my circuit. So actually, there's one feature in this, but it is not generating the Bode plot in correct way.
Okay.
Let me show you.
What is the kit you have? Can you name the kit? I have it.
ADL and 1000.
1000 ADLAN.
Yeah. So this is the kit you have.
Okay. 1000. Hmm. Okay.
Let me just look my circuit. Okay, I might take a minute or two before that someone can ask them.
Okay, anybody else have any doubts? Okay, let's. So this has a theory component also, or only lab?
We have a theory component, but
Ah,
yeah, we have a theory component.
it's going on, or only lab is going on?
It's done. I mean, it is going on, but the op amps part is done.
Okay. So what and all you will learn in that?
Okay, let me show you. Uh, we have studied filters and all, but this PWM, this
That
is
you will
new for
not
us.
study. PWM and all,
Yeah,
I don't think it will, you'll
so
study.
it's very studied.
Right. So small cell supply operation, fuel supply, AC coupling. You are in which week now?
Now we are in at week 10 actually. So
Week
until
10.
week 7 only, they will be teaching op amps part. From there onwards, it was different topics from week 8.
What is week 8?
So it is
Bluetooth headset. Okay. Come down. Power management. Okay. Week 9.
week 9 also some.
Uh,
Even the yeah,
charging system. Okay, this is different. Hmm. Okay. Fine.
this is the final thing we study about op amps.
Offset. You are learning about this feedback and feedback loop,
Yeah, yeah, we are done. We were
stability,
done in the beginning itself.
and then Bode plot and all.
Stability in
And,
the sense they have, professor have just touched upon.
okay, it's not there basically.
Uh, just he
Oh,
touched upon in one of the lecture. He said with values of QP how the poles change.
Q, what is Q?
Like sir, the pole should be negative for it to be
Yeah.
stable.
I mean, real systems you will get negative pole only. That doesn't. That's okay. But within negative feedback also you'll have stability problems.
No, that
With
details they haven't taught us, I guess.
rhythm control system is
No, no,
the
we haven't. Control
oh,
system we'll be doing in the next term,
oh,
most
oh,
probably.
oh, oh. So you learn this in control system.
Mhm.
Yeah. If you were here, you would have learned that also. Okay, anyway, fine. It's fine. That's why they removed that component. There was another feedback loop component with an LED to drive an LED that they have removed.
Yeah, yeah, that
Yeah,
was not there. But
yeah. Okay, fine. Yeah, you were showing something in the
yeah, yeah.
sheet.
I have actually some a little disassembled the circuit, so I'm just
Hmm.
getting it in all into one place.
Okay. Can anybody tell me why VCM is required?
We are using it in single supply operation, right?
So
So in order to set the bias, I mean the common point, the midpoint will be VCM.
yeah, why?
Why in the sense?
Why not? Why VCM? Why you need that VCM first of all? Problem if you don't have VCM.
If you don't have VCM, basically the op amp doesn't.
Sir, I think for higher gains because for common mode
Hmm.
we get higher gains when at a certain range of voltages when it is at the midpoint. So to
Okay.
offset the values, we are instead of ground, we are placing BCMs.
Oh. So if there are dual supply, what you should do VCM?
Zero.
Zero. Okay. Now, what dual supply means what?
Negative voltage also we will be having plus 10
Yeah,
and minus 10.
what is the positive you are giving?
Sir, if we are having dual supply operation, then the midpoint will be 0 volts, so common
Hmm.
mode gain will be higher. So we
Common
need,
mode gain will be, think carefully and answer. Common mode gain is, okay, that's not, blue curve is not, is that correct?
Is that the op amps that we have are rated
Hmm.
to work within 0 to 5 volt range, and in case we
No,
do
it will
not
work.
have
No, no, try it. Why not try it with 5 minus 5? Why it will not work?
uh, we can't drive below 0 because the saturation will happen at 0 volt for MCP 6004, the op amp that we are using.
Hmm.
And
So
the
MCP
lower part, the
6004
negative voltages
doesn't work with
will,
dual supply. That's what you're
sorry,
saying.
sorry.
MCP 6004 will not work with dual supply. That's what you're trying to say.
Yes.
Okay. So, okay, if it was working with dual supply, then
Actually, somewhere I've read that the filtering will be easier if we do with the DC wires. I'm not
filtering
sure
is,
for the reason, but
okay, I also don't know. Filtering doesn't, filtering. So I'm not sure what that is. I'm not,
If we do
filtering
not
is easier.
add the VCM part to
Hmm.
the input voltage, then the
Hmm.
negative voltage will get truncated because the saturation all means the op amp will already get saturated at 0 volt.
Open and get saturated at 0. Okay. Something is happening at 0. Uh, not
So
there.
the negative voltages in the transients, they will not appear at the output.
If you give a sine wave, you mean?
Yeah.
You give a sine wave and you keep it in feedback, then it will not appear.
Yes.
That's what you're
If
trying to.
we
If I put, okay, I'll do this. I'll have 5 volt VDD, 0 volt this thing. I'll put a unity feedback loop. Okay, that is the non-inverting terminal. Sorry, the inverting terminal. I'll connect to output. Right, it's a unity gain buffer. So what should I? So what should my input be like? So you understanding the
So
question?
what are we changing? We are providing negative supply at the instead of ground at negative means minus VCC. Is it
No, no, no. It's 0.
0 there? And
Hmm.
instead of VCM, we are grounding it.
No, no, no. See, inverting the inverting terminal is connected to output. Non-inverting terminal, I'll put a voltage source. Okay, your sine wave, whatever signal. Will it work?
The inverting terminal is connected to output.
Hmm. The minus thing is connected to output. Short. Okay, I'll put a signal at the positive, the non-inverting terminal. Okay, will it work as a unity gain buffer?
I didn't get the meaning of connecting inverting terminal to the
Okay,
output.
wait. Okay, fine. I'll show you. Give me some time. Do you know the circuit?
Yes, sir.
What will it do?
It's a unity gain amplifier.
So what is V out?
V.
V in. Okay, great. Now I have fuel supply. Okay. So okay, now I have only single supply. Will this work?
It will clip the negative voltages.
Huh. So what's the problem?
So the problem is that it will saturate at zero. The op amp will saturate at 0 volt. So whenever
Hmm.
V in goes beyond below zero, uh, it will already be saturated. So
So this is V. V. Okay. Now tell me what. So for this region, what should I write? This region, what will be the output from here to onwards?
0 volt.
0 volt. Correct. Okay. So now what should I draw for V positive V?
Linear,
Line pass.
Band pass.
linearly rising till VDD.
And what slope?
1.
Uh, Slope of 1. So what's the angle?
Uh, it's negative, so it should be like slant. Sorry, no, it will be rising slope. So 45 degree
45.
till VDD, and then it will go flat.
Okay, can now somebody explain what we should do? What is this point? This one.
This is VDD.
VDD.
We did, yeah, obviously. Yeah, it's one. Okay, now explain what we should do.
So if you add a DC component to V in,
Hmm.
that will raise. Uh, I mean,
DC
Now
bias.
you are giving this. Okay, basically you're giving this now. Okay, and rightly so.
yeah,
Your output will look something like this. Sorry. Yeah. If you take this as a time domain, okay, a bit confused. This is a time domain, and you are varying the input. Okay, so you are giving something like this. Correct. Now, if you take this as the time, we embed the axis also. So what will happen? With the positive, you will get the, the positive part will be okay, but the negative part will get clipped. That's what your people are saying, right?
yeah.
This is how you will get it. So to how to solve this now?
Add
Basically,
a
DC
you
DC
are
bias to
yeah,
the
shift this.
inverting
Yeah, shift
terminal.
this towards the right. So you'll have a DC bias. Okay, and now if you embed a signal, you'll get the complete circuit.
Yeah,
Okay. So if you want to look at in terms of dual bias, okay, when it was dual bias, it says this is 5 volt. Okay. Now how will it look like?
it will go in the third quadrant with
Hmm.
same slope
Hmm. Correct.
till minus VDD.
And minus VDD. Yeah. Okay. So that's what it is. Okay, you understood this? Yes. So I have okay. Now if this is in what condition this will be V in exactly? Is there any condition? How did you say it was V in?
Between the VDD and minus, like the positive and
Hmm.
negative rails.
Hmm.
It will V out will be equal to V.
I didn't understand. What are you, come again?
So V out will be equal to V in only if the out
output voltage is between the 5 volt. So input is between +5 to -5 voltage.
That's fine. Okay, forget supply for me. I'm not asking that. How did you say it was Vin?
So the gain was 1 of the amplifier.
Okay, amplifier,
And
right? Ah,
there is a negative feedback, and
okay.
when there's a negative feedback,
Hmm.
we know that there will be a virtual short.
Yeah.
So
So virtual short between what?
both the terminals of op amp.
Hmm.
Yeah.
Okay,
So
you mean
based
this
on
is a short gate?
yeah,
Okay. So if there is a, when is this virtual short valid? Always?
no, only
When there is
when
a
the gain
negative
is very high.
feedback,
Only when the gain is high.
gain is
Gain of the op amp is high.
high or infinite?
Yeah, infinite. Yeah,
Yeah.
basically infinite is not practically possible. So
Short means it should be in, okay. Okay, fine. Now if it is gain is high, you mean some A. Will
yeah,
it be V in now still?
no.
You know what it would be?
Sir, there must also be negative feedback.
Okay, well, is there a negative feedback? How do you know it is? How do you know if? How do you? What is the test you will do to see negative feedback?
We just tank up. We cut the loop and we give
Now, before
some
that, you should do something. Cutting the loop next step.
Stop
uh,
the supply.
yeah,
Supply with supply.
V in.
We not the source. You disconnect the source.
Yeah.
Okay, not the
Disconnect the
supply.
source.
Supply should be there. Otherwise, it will not help. So
Yeah. Disconnect the source.
disconnect the signal source. Okay, now what you will do?
cut the loop and
Yeah, where you want to cut? Okay, anyway, there's only
let's
one
cut.
loop, so anyway, it doesn't matter.
Yeah,
Yeah. And now
anchor on one side.
which side?
Okay, let's anchor the one going to negative terminal.
You have to rank up the input. You can't rank up the output and say nothing is
Yeah,
coming
yeah,
to the input.
yeah.
So yeah, so you rank up this, and then
So we make sure that output is going down or decreasing.
okay, what do you think should happen?
Yeah, it should decrease.
It should.
Decrease, right?
Yeah, why?
Because right now it just acts as a comparator.
Okay.
Yeah,
So what is the output now?
output will be minus supply the negative supply voltage.
No, 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 no. They just okay, some
Minus 8 times the
Yeah,
yeah, okay. So minus a times the whatever v minus. Okay. So what is the output in general? In general, the output will be v plus minus v minus. Correct.
yeah.
Yeah. So now can you tell me what? So now, hmm, okay. Now can you explain from here? Anyone? Yes.
What is the question?
Can you explain now? Can you explain what how this circuit works?
And now we made sure that there's a negative feedback.
Yeah. For yeah, there is definitely a negative feedback. Now then what?
So the V negative, the voltage at the negative terminal would be V in.
I mean this terminal will be v in. Okay.
And then Q out should be,
Okay. But this equation won't work, right? If that's
yeah.
the case. What's the problem? You are getting zero if that is the case.
Yeah, ideally we think in this case A is infinity, right?
Okay. So A is not. You said you infinity is not possible. Some large value we need to put.
Oh,
Okay. But how is the circuit working? Are you understanding the question?
yeah, yeah.
Anyone?
Is it like that virtual shorts concept doesn't work and there will be some difference always?
Okay, don't do it slowly. Okay, what is this? Okay, V in, don't assume here. What is this point if V in is not there?
V out by A.
V out, that's it, not V out there. V out.
Oh yeah, V out.
V
Okay.
out. Okay.
Hmm.
So what is the equation now for V? A times?
V in minus V out.
So what is V out?
V in by sorry, A times V in by 1 plus 1. Yeah.
Correct.
Yeah. Yeah.
So what is this difference? Secondary one. What is this difference? Basically, a V in minus V out. What is it? That's the V difference.
1 by 1 plus 1. Times
From
V
V in by
by
1
1 plus
divided
1.
by 1 plus a.
Yeah.
Now can you explain what is going on? So explain what can you explain virtual short from this?
So V in minus V out, the difference is means since A is a large number, this
Hmm.
is means the difference is 0,
Zero or close to zero?
Close to 0.
close to 0.
Close to zero, not zero. Okay, so be careful. It's always close to zero. Okay, it's not. If you say zero, then this problem starts. Okay, so V in is the difference between these 2 points. That is, these 2 points is very small. That's why you. That's what you mean by virtual short. Okay, you can only apply virtual short if there are two conditions. One, there is a negative feedback, and two, gain is infinite. If A tends to infinity, then only you can say that this VD is zero. Otherwise, it will not work. Okay, so that's
Yeah.
the thing. So you will have so if you swing, and also one more thing, if you swing between, you have a very large output swing. Okay, say this is a VDD and this is ground. It's swinging between this swing. Okay, there will be a finite swing at the input also. Okay, you can't ignore the swing at the input. Okay, keep that in mind. Is that a problem to you? I don't think this will be a problem for you guys, but yeah, if it,
Yeah, no, circuit is ready. Can I show it?
yeah, sure.
Okay, so
Wait.
yeah. Um, Sorry for the background noise actually. I'm getting
Okay.
okay, this is an if you okay, I guess my screen is visible.
Hmm. Yeah, what is that? The beginning.
Okay, when I give 130 hertz, I'm getting this output.
Any other frequency will get the same thing?
No. If I decrease the frequency or increase the frequency, it is attenuating. So if I make it 50, it is getting attenuated. If I make
Okay,
it
so you
like
can ignore the
200,
initial part, only look at the,
yeah.
yeah. Fine.
So even though if I'm increasing the frequency, it is getting attenuated.
Yeah, what you have to do is you have to go with a linear. Okay, what kind of plot they have asked? Logarithmic or linear frequency response?
1 second.
Sweep 125,
So
yeah,
it
do
was
it linear, it's okay if you do linear also.
okay. So we have to manually do this if you do it
Yeah,
in
you
this
have to
way.
do manual. It's not
Actually, there is
possible.
some software. Let me show it.
Okay.
So
Is there?
there is an extra feature.
Hmm.
So here there's an option as Bode plot. When we click this and we select the values to sweep it from 10 hertz to, okay, 10 kilohertz is practically not possible with this kit, 5 kilohertz. And if I try
Make it
to,
100. Make it instead of 10. Make it 100.
okay, so if I make it
Ah,
and start
okay.
to sweep it,
Ah.
that's the problem. Oh, previously I got something, but I'm not sure why I'm not getting it. Okay. Oh, sorry, it's crashing, the software is crashing. Okay.
Amplitude is it? What are the amplitudes you are getting? Wait. What amplitudes you have set for the signal?
Uh, that's what I'm not sure if we can control the amplitude. Basically, it's sweeping with 5 volts only, the amplitude.
That won't work, right? It will give
Yeah,
non-linear.
so let me try controlling if I can.
Try making it a small amplitude and then try this.
Okay, so let me rerun this.
Hmm.
Okay, yeah, now it is working. Shall I make the amplitude even much smaller?
Much smaller, as small as possible.
So shall I make it like
Make it in
2.6,
millivolts if possible.
2.6 and 2.4. Okay, 2.4 and 2.6.
Wait. It's wait. What should your signal should vary? How are you connecting it? This is directly a sine wave. It should be from 0 to something, right? So what does this mean?
We are running this in common mode voltage.
Okay.
Okay, it's completely going this.
Hmm,
Completely.
that's not good. It's going up. Minimize the border plot thing.
Okay.
What's happening to the
Shall I once? Okay, I'll rerun the border control and then minimize.
minimize this? Okay.
Yeah, this is what happened.
What is what? Blue is what?
No, blue is
Sorry.
nothing. Green is
Ah,
the input. No. Green is input and orange is output. Yeah,
there is a gain.
yeah. There is a gain.
That's
But
not
I'm using
correct.
the same values from the simulation.
Make it 2 point. Okay, it doesn't matter. You can give DC also. It doesn't matter. 2 point. Why the frequency is changing? Wait, I'm not understanding. The word brown is output, right?
Ah, yeah. Brown is out. Green is in.
Why frequency is not changing for brown? Is it correct or the connections?
I guess my connections are correct.
Frequencies
I
are
double checked.
different, right? Both frequencies are different.
So the way it works is there something we have to change in the settings? Sir?
I don't know how this border works. Generally, what people do is you give a sine wave and you measure the output amplitude and take the gain as the ratio. You do this for multiple frequencies and you get your border plot.
Okay, even you people do it manually.
We don't have a signal. We can't connect signal because signal source is different for us also. Signal
Oh,
source is
okay.
different and the oscilloscope is different. So we'll have to do it manually.
Okay.
So yeah, you should. I think you should also do manual only. This is not
Okay,
correct.
then manual
Try
something
work
only
out
works.
if it possible work out, but for data for submission, you just submit the
Yeah,
plotting.
submission sake,
Yeah,
normal
do
plan.
manual. Okay, there is no. I will
So
fix it.
already passed the deadline, sir. Yeah.
Hmm. Okay. So after this, what explain? This is okay, right? I think I hope this is
Y-
clear.
Yeah, if I manually do it, it's fine. I think
Hmm.
something we have to fiddle around and figure out
Hmm.
what's wrong.
Okay. Manually, you're getting this thing. Is it okay? The outputs.
Even manually, we are getting some gain.
Then okay. Gain is R. I think what is it? The R2 by R1. I think gain is correct.
Mm.
You'll have inversion, but gain will be R2 by R1 at resonance. Then your resistance values are not correct. If you have a lot of gain, then your resistance values are not correct.
Okay,
Capacitor of
so
what you're using? 1 micro.
1 micro.
Probably it's too large.
But in
What's
simulation, it is
the?
working fine, right?
That is not the op amp is different. No, that this op amp
Okay,
is
here I'm
different.
using an universal op-amp.
So try with 1 micro. I'm not sure if it will. Is 1 micro is too high. See,
Okay.
stability wise, this is what will happen. I think the stability is off. Check the data sheet for 6004. What is the output load, maximum output load you can put? Okay. You can't put a big load like that.
Okay.
It won't work.
So all these things we will figure out as we go through the other courses. Or all these things we will figure out as we go through other courses. Or
No, this is stability is not covered, right? So I don't think this will be easy.
okay.
Basically, check the output load. Okay, is there a unity gain frequency somewhere you can estimate some things? Wait, load cap. From different load cap. RL. What is CL? What are they using CL for?
Mm,
How much is CL?
maybe, so that will
1 micro or 0.01 micro. We do local bypass capacitor. No, that is bypass. You are what capacitors you have?
I have almost all the values.
Try
I
with
mean
10 nano, which I think it should work. 10 nano should
10
be.
nano. So
Resistors will go up. I think that you can manage.
so we swap this 1 micro with 10 nano.
No, it will not work. No resistors you have to change.
Okay, I have to change the whole circuit.
Change the whole circuit. I don't think 1 micro will work with this. 10 nano, I think it should be fine. Wait, I'll just check it. Let's see.
So we have to decrease the capacitor and accordingly all the resistor values.
That says 500 pico. They are saying 500 pico. Oh, that's too small. Yeah, I think 10 nano should be okay. Nanofarads, if you use it, should be okay. Pico, the load is pico. Yeah. Try using nanofarads, it should work. Okay, I think your gain problem
I'll
should
have
be
to
sorted
swap
now.
the whole circuit values.
Yeah. And also the current will, small signal current is also high. If you use micro. Is that correct?
Okay.
Impedance will go down, right? If you increase
Yeah.
capacitance. So Yeah, current will also, so small signal current will also be high. So try to reduce the currents. It will be okay.
Okay.
Yeah,
So
reduce the capacity should be work. If it doesn't work, then let us know. Okay, you're getting some gains or something, then it
sure,
should
we will do
work.
it and
Hmm.
post on with
Okay.
this post.
Anybody else have done with this nanofarads? All of you have done with micro only. Hello.
I think
You
most of us have used the same micro only.
okay, use nano. It should work. Oh, okay. So you understood what this whole thing is? What are we trying to do here?
So we are trying to
No,
reduce
sir.
the load.
No, no, the whole experiment, whole lab. What is the goal?
We are just trying to amplify the input signal and make sure to drive the amp speaker.
Drive the
Okay, so we are selecting, I mean, we are making a selective amplifier, a particular frequency selective amplifier.
okay.
So only two frequency values it will be allowed. It was
Hmm.
a narrow band pass filter because the
Hmm.
QP is 10.
Hmm.
So those two input, I mean, if the signals have those two frequencies, the
Hmm.
input has those two frequencies, it will pass it.
Hmm.
And then that will be, I mean, we use this the other whole amplifier to drive the speaker.
Drive the what? Drive what?
Speaker.
Okay. Why
Yeah.
why you need why you need that? What drives the speaker?
I
How are you
mean,
driving the speaker?
the whole thing, the whole class D amplifier which we are making.
Hmm. So why is that required?
So our input signal doesn't have enough power to drive it.
Input doesn't have enough power. What you can't you mean you can't connect a voltage source there and you get the output.
As far as I understood, so if you directly connect it without a driver,
Hmm.
so it will affect, right? The output impedance of your source is not zero, so definitely your output will be affected.
Output impedance of the source is not zero. Oh wait. Uh, output impedance is not no. Come again? I didn't understand. Output impedance is not zero. Wait.
Yeah, whatever the source we use, we can't make sure, right?
Source. Okay. Okay. You have a voltage source. What do you mean? The source resistance is
Yeah,
not
yeah,
zero.
yeah.
Okay. Ah.
So then it will make a resistive divider, and we meant it to given one particular voltage, but it turns out to be some other voltage.
Hmm.
I mean, this is what I understood. I'm not sure if this is right.
Okay. So yeah, whatever you're trying to understand what you understood. So voltage 21. Okay, why the resistive? What's the problem with the resistive divider? Okay, it's some small only, right? What do you think the Rin of the voltage source will be typically?
Sorry?
Typical
Okay.
voltage
I'm not sure.
RS source resistance. What it will be typically?
I'm not sure.
Typical, some small, large, between 10K, 10 kilo ohms or 1 kilo ohm, so a few ohms.
Very small, sir. Few ohms, maybe.
Okay, few ohms. So how is that a problem?
So the
Yeah, why is that a problem?
Sorry?
Yeah, why those few ohms are a problem? A few small, right? So why it is causing a big problem?
Okay, so what's the actual reason?
I'm asking, man. I know. I am
Okay.
asking the question. Why it will.
Okay, so as far as I understood, then this particular, whatever the source we have, it doesn't
Hmm.
have enough power to drive. So the signal power itself will be very low. So
Hmm.
it is not enough to drive the speaker. So what we do usually with an amplifier was we amplify the power. So there
Okay.
are various methods to do it. We
Hmm.
choose the Class B amplifier.
Hmm.
Here we use a pulse width modulated signal.
Hmm.
So actually we haven't. been taught about this, but as far as I have studied from various sites,
Hmm.
when we use a pulse width modulation,
Hmm.
there will be less. Basically, in Class D amplifier, there will be more efficiency.
Yeah. Okay.
But I'm not sure why that efficiency won't be there in Class A or Class B. But
In a
Yeah.
class A, there will be a residual, like the current will pass through the speaker even if there is no signal, so it will have more losses
Hmm.
compared to the class D. That's why class A is less efficient. It has more power loss.
Okay. The power loss is more in Class A.
So class A, we always have to keep the power up at full amplitude. So that's why even if we do not have the input signal,
Hmm.
the output is driven at the peak voltage. That's
Okay.
why voltage loss, sorry, power loss there. But
Hmm.
in class D, since it is digital signal, the uh, uh, it's not driven by the voltage change, but uh, uh, the duty cycle actually determines the frequency of the uh, input signal at the output side.
What duty cycle determines the frequency?
Uh, yeah, I mean it's modulated, right? The
Hmm.
Yeah, so uh, we can keep means the peak to peak voltage will remain same in a PWM signal.
Okay.
So
But I thought the input for this your speaker is differential, right?
yes,
So will it still be same?
so these are two opposing pulses that we are providing to the speaker.
Hmm.
So they are totally out of phase.
Okay.
So and hence their difference will actually drive the output of the speaker.
Hmm. Okay. Fine.
I am not sure
uh,
if I'm going in the right direction. I'm just
Hmm.
taking clues from your questions or your line of reasoning.
Okay. Fine. Okay.
So can you repeat what the main question is here?
Now, why you
Yeah.
need the Class D amplifier? Why can't you just drive it with a source? Take a
so
sine wave generator and generate it through that node, so you get the same thing. Why you need a Class D stuff?
uh,
Mostly because of power, we need to amplify the input signal is very small typically. That's why.
Input
Yeah, I
signal.
don't know.
It is also small, right?
Sir, I think because PWM outputs can be driven by digital circuits.
But okay, it's all analog only. Right? We don't do any digital stuff here. Most of it is analog. Only few
So we
digital.
have the resistance at the output is like of the order
Hmm.
of 16 ohms or
Hmm. Few ohms.
32 few ohms.
Hmm.
So there's a
So
mismatch of resistance at the input side from what we have on the
okay,
output
what's the
side.
current drawn from?
The current requirement will very high, so all the
Ah.
transistors, everything have to be high, high current and high power.
We
So
Ah.
it's
we
easier
can't
that
drive
we process
directly.
the signal in low voltage, then
Hmm.
amplify at the end to
Hmm.
drive the speaker.
Okay. So fine, that's what it is. So the current is very high. You need a lot of basically the power current is very high. That's the problem. You need very high current. The power requirement is also very high. Your signal
Yes.
sources cannot fulfill your power requirement. So you need a amplification. That's what it is. Somebody said that already. So yeah, I wanted to come to the current argument. So current is very high. Okay. So what is
Uh,
this prop? Yeah, go on.
sorry to interrupt, but
Hmm.
why most of the people prefer Class D? Because usually we use an amplifier in sound system or power system.
Hmm.
But there's no limit for power, right? We have ample amount of power.
Where I didn't understand that. Where we use
So, I mean, I have read somewhere that people usually tend to use Class D amplifier in most of the applications.
efficiency is very high, right? Lastly,
I
that
mean,
was it.
in our household appliances and all,
Hmm.
efficiency, I mean,
It matters.
we have
If
ample amount of power, right?
There is
but
also a lot of
if
heat.
somebody comes and says, okay, if somebody comes and says, I'll have a 10 watt lower power, which one will you prefer?
Uh,
If
yeah,
you want to use a earbuds, okay, which has to generate a sound. Okay, speakers are there in the earbuds. Do you think everybody doesn't use speakers, right? Uh,
yeah,
so if their efficiency matters a lot, correct?
yeah,
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 it's battery operated devices. You
yeah,
can't whatever efficiency you can squeeze out, it is better. If you have to keep charging every day, I mean most of the good battery usually lasts for 2 days, right? For general use.
yeah.
So if you want to charge every hour, what do you think? Or which one will you prefer?
Okay. So
Efficiency
quality-wise, which
matters.
is better?
Huh?
Quality-wise, which is better?
I mean, once you convert things now, people don't use this kind of because there is a lot of digital processing involved now.
Okay.
So this is analog speakers. So now people are also trying to do digital stuff with speakers, right? It's not your speaker is not just simple vibrating analog stuff nowadays. So digital processing is involved. So people generally tend to move towards Class D. Your speaker is
Okay.
not just as simple as an inductor with resistor.
Okay.
Okay, so there are now people are using arrays, speakers with arrays, so that digital processing is much easier in that case. So Class D is preferred in that sense.
Okay.
Okay.
So,
There are other this class the business is all people generally don't even stop defining this class system also. People are now just an amplifier. They don't even go for this class system now. They are designing much more complicated amplifiers now. Okay,
yeah.
so this class business is also fading away slowly.
Yeah. So,
So what is this
one more
problem
thing.
with this? Go.
Okay, okay. No, this is just a request. So you can
Uh,
go ahead. I'll ask it then.
what is the problem with this non-overlapping? Why you need this non-overlapping thing?
Otherwise, the input
Sir,
and the output
because
will
if it
short.
is overlapping, then
Hmm.
there might be a possibility that in some cases the NPN and PNP might be both on, and which may create a short between VDD and ground.
Hmm. What's the problem with it?
Sir, then it will be a short circuit basically.
Okay, so yeah, so what?
High amount of current will pass through the transistor. The
Ah,
transistor can heat up and
yeah.
destroy itself.
So yeah, I just want it up. It will supply your speakers will not work. Okay, there are other circuits that will not work. The speaker may get damaged. The transistors are designed to draw that much of current. That's why there is huge amount of current passing through them. These are high power transistors. Okay, your transistors will be fine, but your speakers may get damaged. Okay, that's the problem. Okay, because there is high current, your speakers are a small load. Okay, the current may go in there also. You don't want that happening. And also you're using differential stuff. Okay, so that's another problem. And the speaker and also your transistor will start getting heated up, and after some time that will also get damaged. Okay, so you should be careful. So you don't want both transistors to be on at the same time. So you understand BJT, right? Is it alien to you, or is it people are still teaching it, or they stopped completely?
We had BJT concepts in our last course,
Hmm.
But it
electronics.
was like it was very less.
Yeah, it doesn't. You don't need a lot of. I mean, just a basic idea. Here, what you need to understand, it's a switch. Okay,
Yeah, that
so
much.
PNP will act as a positive switch, NPN is a negative switch. So yeah, if that is known, it's okay. You don't
Yeah,
know
not
much
much
more
more.
than. And what about this LM339? You need a collector, some output, something, some 1K I saw. What is that? What is the point of that?
That's a pull-up resistor. So it's open means output terminal of that comparator is free-ended. Like it's not what do you call it? I forgot the term that
They are
was.
giving it as open collector.
Yeah.
So
So
what's the problem with open collector?
So we may assume that some floating point voltages will be formed. What is it?
Okay, okay. Well, you just type that LM339 and see how the circuit is. You'll understand.
Only there is only one BJT that connects the pin output pin to ground. There is no
What
upper
BJT? What type of
the
BJT?
internal. Uh,
Correct, correct.
that
What
I have to
type?
check.
NPN, PNP. What is it?
That we have to check with the
Is it
circuit.
man, it's not that difficult. To ground. What kind of transistor?
Yeah, it was an NPN.
NPN. Only NPN you can connect to ground, not PNP.
Yeah.
It makes sense, right? So yeah. So there's
Yeah,
an
yeah.
NPN ground. So what?
So the output pin can only go to ground
Hmm.
and not to the upper power rail. So we have
Okay.
to
So
use a resistor to
okay.
pull it up.
So how did you decide the resistor value?
Uh,
Correct.
the current limiting capacity of the transistor.
Okay, the aperture is not even what kind of value you should use. You can use a very high value or a very low value. That's all I'm asking. Can I
It
use
should
a very
not be
large?
very low value resistance because
Hmm.
otherwise the current will be high,
Hmm.
which may damage the
Switching will be
transistor.
difficult.
will be
Hmm.
It should be in like kilo ohms range
Okay, if it
or
is in mega ohms,
200 or 20 ohms at
and
least.
if it is mega ohms, what will happen?
the current will get limited for the output.
No, think again. Okay, what you
Sorry.
want is basically it's a switch. Assume it's a switch. Okay, and answer. You said it cannot be small value. Okay, it can be large.
If it's very large, then current will be very low.
Okay, so
So it should at least needs enough current to switch between the higher and the lower. It's a comparator, so
hmm. Okay, the transistor looking in, there will be some resistance, right? So
yeah.
it's a, like a variable resistor. Okay, forget switch. It's a, like a variable resistor. Can you now answer? When it is open, is it truly
So if it
open?
is open, then the means the current will get routed into the transistor itself.
Correct.
Since it will be parallel to the resistance on the output.
Parallel. No, no, not parallel. Okay, when it is open, there is some resistance. Okay, now if you use a very large resistor, what will happen to the output voltage?
So output voltage will be very small because the majority of the voltage will get dropped across the high value resistance.
Hmm. So you have to use, okay, that's the reason you'll have voltage division. Okay, if you use very large resistors between for your from VDD to the collector, so the drop across that will be much higher. So you need to make sure you should select some value in between. So you can't use both values. You can't use very large or very small. Okay,
Okay.
that's the way. Okay. Yeah, okay, one last question. If you go to, can you maybe show me the oscillator circuit?
The first experiment. Huh?
First experiment.
Okay. Let me-
For the silent.
Yeah, this is the slow test.
So how does this work?
So this is an integrator, and
Which is what is an integrator? Which
the
part?
integrator it integrates the input only.
Which part is an integrator?
Yeah, this first part. I think my
Okay.
cursor is visible.
Yeah, visible.
And this is a comparator.
Okay.
So, for example, if we set this particular, let's assume that the output here is 5 volt, I mean VDD 5 volts.
Hmm.
Then the same thing comes here, and if the initially if the charge, if this particular capacitor here is it is 0,
Hmm.
it starts to charge up.
Okay. Why
Okay,
it starts charging?
because we are giving some current, right?
Okay. Yeah. Yeah. Slowly answer it slowly. Go
Okay,
slowly. What is
okay,
the R1? Okay, what is the difference between what is how tell me the two terminals of R1? What voltages they are in?
okay. So the left terminal it will be 5 volts, and the right
Hmm.
terminal it will be 2.5 volts.
Okay. So what's the current?
It would be 25 by 2.5.
Hmm.
Sorry,
25 by
sorry,
2.5.
2.5 by 25.
Okay.
Hmm.
Yeah, go on. So about 100 micro, correct?
Ah, yeah.
100 micro amperes. Go on.
Mm,
Where will the current go?
it will go through the capacitor itself.
Capacitor. You said that the output is 0. Okay. Now what will happen?
So as it goes through the capacitor, the voltage should decrease.
Which voltage?
1 second. As the current is constant, there will be
Hmm.
an uniform change in the voltage.
So can you come again? Current is constant. Huh.
There will be a linear change in voltage.
Okay. Okay. Go there. So what?
Okay, so since we assumed our output here at the LM33 is 5 volts,
Hmm.
the voltage at the positive terminal should be high. I mean, it should be higher than 2.5 volts.
Okay.
So with that assumption, initially the voltage at this op amp, first op amp is 5 volts.
Hmm.
It starts to decrease.
Okay.
Yeah, it
Why did
starts to decrease
why it was 5 volts?
because only then our assumption gets validated, right? Because it's a comparator.
Hmm.
Yeah, for a comparator, the positive terminal voltage only if it's greater than the negative terminal voltage, your
Hmm.
output will be 5 volts.
Why you took 5 volts? I don't understand.
Okay, you mean
You
some
said
any
5 volts.
value above
You said,
2.5
yeah,
volts.
correct, right? You said 5 volts. So I didn't understand why 5 volts.
Okay, let's just to make sure that the initial condition is VDD.
Okay, fine. Okay. So tell me what is the initial condition? Or what will be set? What
Sorry?
you if all fine, you just tell what is the initial condition properly. What is what? Positive terminal of comparator is what?
It is greater than 2.5 volts.
And how much? And what you want to set it?
I want to set it at 5 volts.
5 volts. Okay. Output of comparator
It is 5 volts.
5 volts. Okay. So yeah, that's fine. Now what is it? Okay. So what about this output of the integrator output? What is that?
Uh,
What do you want to set it at?
oh, mm. I want to set it at 5, but if I set it at 5, there's no use. Am I
Hmm.
doing something wrong?
Yeah, that's what I'm trying to ask you. What will you set it at? Are you getting what I'm? Anybody else can try this? You understand?
So what is your question, if we may get that?
Basically, how it works. That's all I want to know. You said you want to
So
zero.
the right side we have the comparator which acts as a Schmidt trigger.
Hmm.
On the left side we have an integrator, op amp working as an
Okay.
integrator.
Okay.
So the comparator compares voltages on its two terminals, inverting and non-inverting terminals,
Hmm.
and it switches between its saturation levels. So it
Okay.
generates a pulse uh, signal,
And
a square wave signal.
okay.
Okay, and we can configure the duty cycle using the ratios of R2 and R3. So that signal
Configure.
is fed
Oh,
to the,
hold on. Configure duty cycle.
yeah.
Are you sure?
No, I'm not sure about the duty cycle part. I'm not sure,
Hmm.
but the
It is 1:5. So do you think 50 what is our duty cycle?
no, I'm not sure about 50% duty cycle, or what percentage of duty cycle means what
Hey,
would
you are
be the
seeing, man, you are seeing all the experiments. What is the duty cycle we are getting?
sorry.
What is the duty cycle we are getting? You seen the first
We are
experiment, right?
getting a 50%
Hmm.
duty cycle here in
Okay,
this one.
so yeah, so this circuit gives you 50% duty cycle. So do you think R1 and R2 and R3 will give you, if you vary it, you will get duty cycle variation?
Uh,
We'll get a variation in duty cycle if we change the negative terminal voltage.
Ah, right. Fine. Good. Yeah, that's correct. If you turn a negative terminal, you get duty cycle variation. Yeah, that's correct. So, okay, now can you explain how this circuit works?
The overall circuit,
Yeah, overall. Why you got
yes.
confused? What happened? You're on the right
I'm
track
not
only.
sure.
What happened?
So I'm not sure how to define the initial voltage of I mean, initial output voltage of first amplifier.
Okay, fine. Okay, that will be confusing. Okay, don't forget initial. Okay, I'll put you another question.
Hmm.
Let's say, what should I say? The
Sir, like
comparator
if
is yeah. Sorry.
sir, if we considered initially the output of the comparator to be high,
Hmm.
then the output of the operational amplifier will also slowly start increasing. And once it starts increasing at one point,
Wait. Slow down, slow down. Which operation amplifier? Integrators.
yes,
Why?
because sir, the initially input to the integrator is just DC 5 volts. So as it is an integrator, only considering it as an integrator, we can say that it will behave as a ramp only.
Okay, what kind of fan?
like the voltage will keep increasing with slope of 45 degrees until the output of the comparator
No, both statements are wrong. Why 45? What is the output of integrator? Can you just
it is the integral of the input.
how? What is that? Just integration dv dt.
That's a triangular wave signal.
No. Integrated. There is a V in at R1. What is V out?
V out is a ramp signal.
Forget ramp. There's some V in. What is the output?
So it's 1 by RC times integral V in.
Something. Are you missing something?
Minus 1 by r.
Okay, yeah.
Correct. That's important, right? So now can you explain what will happen?
Okay, sorry sir, not 45 degrees.
Yeah.
Sir, so like if the output of the comparator is 5 volts, the output of the integrator will slowly start increasing. Because
Okay.
it is integrating and input is a DC 5 volt.
Okay. Do you think it will be increase or decrease?
Increasing, sir, up to 1.1. And after a certain
What is
point,
the output of integrator?
So it's minus sign, so it's decreasing, negative slope.
Decrease.
Negative
decrease.
slope.
Then
So then as soon as it crosses the VCM level on the comparator side, the comparator will saturate for the negative voltage, and then that will be fed back to the integrator. So integrator will means in that case there will be a positive slope on the integrator. So from that point onward, the voltage will start increasing linearly.
Okay. Yeah, okay, that's fine. Okay, so can I go to the circuit and show the circuit? I have one question. Go to the circuit.
You want me to show
Yes,
the
yeah,
one second.
show the circuit.
Yeah.
So comparator is not like it's still a linear only. There's still a linear part to it, right? So if the input is 0, what is the output?
Output also will be 0 of that comparator.
It will be 0, correct. So go to the circuit.
Yeah, 1 second. So, is there any chance that our final experiment we can submit at the campus itself instead of doing the house?
I don't know that you are asking.
Because we don't have a speaker, so how can we show the output?
I have no idea about that part. I should ask someone. Is there in the course somebody is there? Okay, basically what I wanted to ask was if all nodes are at 2.5 volts, how will the circuit work? Are you getting the question?
So Schmidt trigger is basically works under hysteresis. So while the voltage on the input side is increasing, the switching level will be slightly higher than when compared to the reverse cycle.
Okay.
and the voltage is decreasing.
Oh, yeah. Okay, that's fine. So what I wanted to ask is, okay, so if all nodes are at 2.5 volts, okay, the output of comparator, everything is at 2.5, will it work?
Then it won't work. Right?
Yeah. Is that a problem?
Yeah, it is a problem.
Huh?
I mean, it is a problem, but it doesn't happen in reality. Right? There will be at least a
It
little
happens.
difference.
Why not? It will happen many times.
Oh,
This is a big problem actually.
okay.
Did others understand the question? If all nodes are at 2.5 volts, will it work?
Basically, if the all nodes are at 2.5, then the current through the capacitor itself turns out to be zero.
Yeah, everything is zero. Resistor also zero. Everything is zero.
Yeah,
So
everything
nothing
just gets
happens.
freezes out.
Yeah,
Yeah.
nothing happens. So it's actually another stable point for this circuit. Okay, right. It's a
Okay.
unstable equilibrium, but it's an equilibrium. There is an equilibrium for it.
Okay.
So this is actually this is you will see this multiple times. So whenever you see unstable, what do you think you can do to get
You
rid
can
of this
just
unstable?
you can just connect one of the node to ground for a moment,
Hmm.
and then you can continue.
Or even easy way,
Sorry,
or another easy way.
usually there you can
Uh,
discharge the capacitor.
no. Discharge, it's okay. It will still not work.
Okay.
Still not
Yeah,
work.
it won't.
Discharge is still not work. Both voltages are same. It will still not work.
Yeah.
Capacitor, you don't do any connection stuff. You can do something else. Basically, it will not oscillate. You have not seen any oscillations. Everything is at 2.5. Correct.
Yeah.
So what you can tweak?
So when we increase the common node voltage,
So what will increase it or increase keep it there, or what you should do?
we increase and get it back there, then it will.
Yeah. So this is a problem in analog circuits called startup. Okay, you need to, because there are, whenever you have an oscillator that may have an unstable equilibrium. So if you want to disturb, you need to basically disturb that equilibrium. So you can do any technique, many techniques you can use to disturb that equilibrium. Okay. So you'll
So
also see this in many other circuits also. Okay.
is this even applicable for the simple 555 timer?
Not sure. 555 timer.
Because
Mm,
I have encountered
this
this once.
I think, yeah, if is I think you can just basically what see why it will oscillate in your case is because your when you the at the event of turning on the supply itself, it's not it's not a step response, it's a ramp kind of response. You're turning on some supply, so that is enough to disturb your node voltages. Okay, so that is enough to start up the circuit, but in general it may not start up. Okay, so it's there.
Yeah.
Hmm. So yeah, that's it. Any other questions you have?
For now, that's it. But
Hmm.
I think please, actually, the deadline decision is also taken by the TS. So.
No. We don't take any decisions. It's up to the.
But do you
Leader.
think the final integration is possible without a speaker?
I that you have to ask. It is not in our hands. You need to ask the instructors once. We don't have this thing, so that we can't decide. TS don't have power regarding deadlines and all other things.
Yeah, because we don't have any direct access to the professor, so you are the only one.
Who is the instructor for this? Saurabh sir, right?
Saurabh, sir. Yeah.
Okay, I'll ask. Okay, we'll look it. Okay, speaker. What was they haven't informed anything before?
Sorry?
Did they inform anything about the final experiment?
In the sense about the deadline or?
So what you should do finally?
Wait, I will. Check.
22nd December. Okay.
Okay, the final experiment. So they have just set it as top level integration.
Okay, I'll ask.
As of now, the deadline is on 18th of December. But
Did they ask you to come here or
no, we'll be coming there at first week of January.
first week of January? Not sure. Do you have inductors?
They haven't provided inductors, so
So
most of us won't. It
actually, I
doesn't
don't
have.
know if that is if they don't provide. I think speaker is also. I don't know if they can provide it now. So I think it will be like you should just show the PWM. Will be your final thing. I think if you show the PWM with this thing, it's okay. I guess.
No,
Fantastic.
what the thing is here, the problem is
Hmm.
we probing the things and then we only recording the video and
No, we'll ask. I
uh,
think there will be a evaluation. We'll ask you to show stuff one by one.
we are saying at the campus, huh?
No, not. I mean, we may do online meet and we may ask you to. I don't know how it will be done, but I'm guessing.
Yeah, please, that would be really helpful because recording the video is one of the biggest problem for us.
Okay, okay. I'll ask.
Because
We'll see
yeah,
what.
now we have to take care of two things. We have to take care of what output we are getting, and also we have to take care of how we are presenting it.
Okay, okay. I will
And
see what. Yeah.
above all this,
You can't
sometimes
do
we face
screen
the
recorder. Wait, you can't do screen recording.
we can do, but it was like we have to integrate everything once again. So we have to edit it.
Editing and will just send whatever you did. You just send it. That's all. Editing and all. We
Okay,
don't have.
so if it's fine, we can send it at two parts. Like we show the circuit
Hmm.
in one video, and the other video
Hmm.
we screen record. Just we won't show the
Okay, we'll
circuit
see.
in that
Okay,
video.
okay, okay. I'll ask what to do about this final integration.
Yeah.
Okay, what is the deadline for next experiment? Tomorrow.
Tomorrow it's for the adder.
Hmm. Then that is week 5 or week
Ah,
4.
week 5.
Week 5. Okay, so week 4? What was it?
It was the BPF.
Okay, BPF deadline is tomorrow.
No, BPF deadline is already passed.
Past. Okay, that was yesterday.
Not yesterday.
Okay, it's already passed. Okay. Anyway, fine. Tomorrow is adder. So adder, I don't have any doubts in adder. It's okay, right?
Oh, it is okay, but once again, we will fix the BPF circuit because without BPF circuit, we can't
Yeah, nothing.
demonstrate
No,
anything.
Yeah,
no, we have to fix all circuits now. So because everything should work properly, then only your output will be proper.
Yeah, at
sir.
least for week 5 submission, we need week 4 to be working.
Yeah.
Sir,
Hmm.
I don't know if you are the right person to ask this, but
Hmm.
if we were to, because we will eventually come for the labs, right? Wouldn't
Hmm.
we will be making the changes to the circuit or the final integrated circuit or not? Would we know that?
I didn't understand what.
Now in the week 6, we will be putting all the modules together in a one circuit,
Hmm.
right? So will we have to change that when we come to Madras, like, for the labs? Are you aware about that?
No, I'm not right.
Because one of the request I want to make is, could we solder this all the components to a perf board? Because
Why?
currently, at least I am
Ah.
facing is the breadboard parasitic capacitance. Since this breadboard is very
No, then there is other.
problematic.
Change your breadboard.
So I have like purchased 3 new breadboard for this analog, and like
Then there is
it
something
is
else wrong. The
for
currents
for
are
me
too high.
for me it is as of now I'm changing breadboard. The output is changing.
See, we have seen this
So I
breadboard
have
issue.
tested
It is
all
general.
boards.
Yeah, here also you are seeing this issue, but I think the problem there is the breadboard. The issue will be the breadboard. Here, see, these people use 3 breadboards for their integration. Okay, you like 3, 4 breadboards together. They have to integrate. You have. I don't think you will need more than 2. Rarely. I don't think you need more than 2 breadboards to
Current
integrate this.
as of now I have put every circuit on one board each.
Ah.
So and
Don't do like that also. You try to, combine everything together. 4 breadboards also is a problem. You don't want to do that also. Try to make compactify your circuit and try to make within 2.
so
Maximum 2.
another
Don't go beyond
second
2.
another problem with that is that while bringing like traveling and all, the
Hmm.
signal
Fine. That
the
you can
connection
tweak.
can get.
Yeah, then you have to tweak some things, right? That is fine.
So for audio, like something as sensitive as audio, it's best if we just solder it on a board. Then we have no problems of like
Are
parasitics or
you
anything.
are you 100% sure that will work coming there? If you, then it's a bigger problem for you, right? If nothing, then you can't even change it here. You don't have soldering stuff here.
So
If
like
something goes
if you
wrong,
have any
what will you
personal,
do?
so
Huh?
assuming if you have a personal soldering and
You
all.
will bring it here and start soldering.
So like
What?
previously students were making circuits in the hostels itself. So
With
some issues will be
with
there.
your soldering gun, you are starting to do. Okay. I don't know. I don't recommend that. So okay. Anyways, I can't say anything for that.
Okay, sir.
It's not a thing. I would recommend you still do it in breadboard only. I understand traveling and all, but it shouldn't be that big of soldering is much more risky than going in a breadboard. That's what I feel.
For
It's
me, it has
extremely.
been like if I'm putting a resistor, the even if I put my hand above the circuit, the output is
Yeah, that
dropping and
happens.
all.
That
Yeah.
unlocks. Yeah, that happens. That's you can't. I mean, everybody will face that issue. That's not a problem. If
So
you
for
just
me,
hmm,
like with the, I have made some circuits. So for me, like the current experience is solder it on a small board so that you do not have any breadboard will interfere it, whatever you do. So if you avoid it, it's best, at least for the audio type of thing or sensitive
okay,
signals.
I just
That's it.
okay. Up to you, but I still recommend you do it in a breadboard.
Okay, sir. Okay, sir.
Okay. Yeah.
One more thing, a final question. Huh?
Hmm.
So basically, I've seen new people will be doing it at 100 kilohertz, the RAM
Hmm.
frequency.
Yeah.
So we are doing it 5 kilohertz. So this particular frequency affects the quality of the output audio, or
No, not much. It shouldn't because all frequencies are scaled accordingly. Your audio inputs are also scaled accordingly. Everything is scaled, so it shouldn't affect much.
then why you people are using like 100 kilohertz?
Which one?
I mean, actually, the analog experiments which IIT Madras BTech students do, they use
Hmm.
100 kilohertz. Right?
Hmm. I
Why like
don't
that,
think
and
that's
why?
what that week. I don't think that's what the speaker stuff. I'm also not sure will you be given speakers or not. That's the I don't know. That's the
Oh,
speakers will take for you or not. Yeah, I
okay.
understood that problem. I don't know if this will work or not. I'll talk with sir and let's see what's
Yeah.
up. Okay.
And also one more request, like, if possible, please, I mean, as you're speaking to sir, please even put this point up. So if
What
possible, when we visit the campus, please try to give access to actual oscilloscope for us. And
is not given?
usually, till all the labs which we have done in the past terms, there
Hmm.
was no need to get an oscilloscope. We have done digital experiments.
Even
Okay.
the analog ones were like doable, somewhat doable by the
It
headlamp.
was just a
But
VTC or voltage transfer plan.
yeah, now we
Hmm.
are even if we use headlamp, we
How
do
many of
not
you
have
are there?
enough
Wait.
boards.
How many of you are here? Number this course
17.
17.
No,
Okay.
no, 13.
13. Okay.
Oh.
Okay. Last 13 members. Okay.
That
Nice.
too, 13 people will be coming in two different slots. Everyone won't come appear in one slot.
Hmm. Okay. We'll
So
see. Okay. Okay. I understood. We'll see. What else?
yeah,
Anything else?
and also yeah, that's a only
Okay.
1 day is allotted for this analog lab. Will
Hmm.
it be enough for us to get familiarized with the oscilloscope and
You said you want. That's what. If you want oscilloscope, then you have to. It's nothing there. Nothing much great about it. Just you have to click to few buttons. You will be getting it. It's very
okay,
basic oscilloscope, not very hi-fi ones. Okay.
okay. So it is
Yeah, it should
almost
be
similar to
okay.
our thing.
Yeah, one day. I mean, we'll be here for many days, right? It will not be like one day only. We should.
Yeah, we stay there for 4 days, but
Hmm.
it is assigned as only 1 day. Rest 2 days will be free,
I don't. Okay,
apparently.
we'll see. We'll see. I think
Yeah, yeah,
but in one day, I don't know if we can familiarize. Okay, we'll see.
yeah, yeah. Please once even put
Uh,
this. with
Okay.
Professor and Victoria, ma'am. And yeah,
Okay.
thank you.
Anything else? Okay. Fine. Okay. Thank you. That's it. Thanks for coming.
Thank you for your time,
Thanks for your
sir.
time.
Okay.
Thank you, sir.
Good night.
Thank you, sir.
Okay. Sir? Ankit sir.